Now children, we will solve some important numericals based on these processes, isothermal and adiabatic processes. And basically I'll solve 4 numerical problem to make you understand more about numerical problem, okay, from this chapter. Okay, so let's start with problem number 1. So problem number 1 says that the initial pressure of a gas is 5 into 10 power 5 Newton per meter square. So let me start with the solution of this problem. So there are two pressure, one is initial pressure, one is final pressure. So initial pressure is marked by letter P1. So I'll mark P1 as the initial pressure. So how much is the initial pressure? 5 into 10 power 5 Newton per meter square. So this is the initial pressure. Okay. Now its volume is compressed. So this is for the gas whose initial pressure is this much. Now definitely this gas has a volume also. Its volume is compressed to 1/9 of its initial volume or original volume adiabatically. Means by what process the volume is compressed? Adiabatically. Means the process will be adiabatic process. So you don't know what is the initial volume. So what I do, I write down let B1 equals to B. Say I'm writing B1 is the initial volume and I consider B. Okay. B the what? This is your initial volume. This is the initial volume of a gas. So what is the initial volume of a gas? B, that is B1, I say as B is the initial volume of the gas. But the question only say that the volume is compressed to 1/9 of its initial original value. So definitely if the volume is compressed by 1/9 of its initial value, then we get final volume. And that final volume is B2. And final volume is nothing but 1/9 of what? B1, because this volume is compressed to 1/9 of its original volume. Okay, which means 1/9 of B1 means what? B. So B1 is B, B2 is 1/9 of B. Now for this process, gamma is how much? 3/2. And this process which takes place adiabatically, this is for what process? Adiabatic process. Now what we need to find out, what is the pressure of the gas in this condition? Means pressure of the gas under this condition means you have to find final pressure. Okay, so let me write that final pressure is P2. So P2 be the what pressure? Final pressure. This is the final pressure of the gas. So how to calculate this final pressure under adiabatic process? So for that we follow Poisson's law, because adiabatic process follow what law? Poisson's law. So I write down from Poisson's law, and Poisson's law can be written as Pb to the power gamma is constant. So then you have learned this part. Pb to the power gamma is constant, but I write the same relation now as P1 B1 to the power gamma is equals to P2 B2 to the power what? Gamma. Okay, so P1 B1 to the gamma equals to P2 B2 to the power gamma. Now to calculate the value of P2, so I'll make P2 as the subject. So I write P2 equals to P1 B1 to the power gamma by B2 to the power gamma. But can I write this way, children? P1, now B1 and B2 both has power gamma, so I write in whole power B1 by B2 with gamma. Okay, now let me substitute the value. Now pressure is how much? 5 into 10 power what? 5. Okay. Now into volume, one of the first volume is B1 is how much? B. B2 is how much? 1/9 of what? B with to the power gamma, and now value of gamma is 3/2. So B and B cancel out. Now 1/9. Now this value of 9 will go in the numerator. So it will be reciprocal. So 5 into 10 power 5. Now 9 I write down in the numerator, and this is 3/2. And you know what is 9? 9 can be written as 3 square. So I write it down. 5 into 10 power 5. That is already there. 9 means 3 square 3/2. Now this 2 and 2 cancel out, which means 5 into 10 power 5 with 3 cube means what? 27. 3 cube is 27. 3 into 3 into 3, 27. Now 5 into 27, if you multiply, it will be 135. Okay, 135 into 10 to the power what? 5. But what I do, I write the answer not in 135 into 10 power 5. I write the answer as what? In the power of, I keep this answer in single digit, because this is in 100 digit. Okay, 1, 2. Now 2 number front I put decimal. I write on 1.35. But remember children, this part, when the power is positive and when you shift 2 number from decimal, your power increases by 2. That means 5 plus 2 means 7. So this is P2 and this is Newton per meter square. So when the gas is compressed, means when the volume decreases, pressure increases. So the final pressure is now 1.35 into 10 power 7 Newton per meter square. So this is the pressure that you need to apply to reduce the volume from B to 1 by 9th of B. Okay, so this is one of the numerical based on adiabatic process. Now we solve next problem, problem number 2. And children, problem number 2 is based on isothermal process, in which we calculate the work done by the gas under isothermal process. Okay, and problem number 2 says that 1 mole of an ideal gas. So N is the number of moles, that is 1. So this is for 1 mole of ideal gas at 127 degrees Celsius. So what is the temperature of the gas? 127 degrees Celsius. Okay, now under isothermal process the temperature remains constant. So we are actually dealing with what process? Isothermal process. Thermal process. Because question says that 1 mole of an ideal gas at 127 degrees Celsius expand isothermally. So isothermal means the temperature, that is 127 degrees Celsius, remain constant. Okay, this is in degrees Celsius, but I can convert into Kelvin also. So what you need to do? Just add 273. Okay, so it is 400 Kelvin. So this is the temperature which remain constant until its volume is doubled. Until its volume is what? Double. Calculate the work done by the gas. So you have to calculate the work done by the gas. But children, in this question, the value of R, actually R is called universal gas constant. Now the value of R, calculation of value of R, I have not explained in this particular chapter. But as I said already, there is a chapter called kinetic theory of gas. At that time, we see how this value of R, that is 8.31 joule per mole per Kelvin, will be calculated. Okay, so this is a constant value, a universal constant, just like your gravitational constant, universal constant. Okay, similarly this constant is also another universal constant, which is 8.31 joule per mole per Kelvin. Okay, now but in this question, if you see what is happening out here, the volume is changing. The volume is getting expanded isothermally, but from certain volume, original volume, to double the original volume. So you do know the initial volume. So let me write B1 equals to B. Say B1 is equal, B is the what volume? Initial volume. Initial also called what volume? I use the word initial or what volume? Original volume. Then B2 will be the final volume, which is double of B. Double of B means the final volume. That means final volume B2 is double the what volume? Original volume. Because questions only say that you need to expand the gas isothermally until the volume is doubled. So final volume which will become double means the what volume? Final volume. So under this case, work is definitely done by the gas, and there is a formula. We use direct formula. I write down definitely work done, okay, by the gas. Work done by the gas is given by W, and the formula is 2.3026 N. Okay, I write down N. This is nRT with log of base 10 B2 by B1. See, this formula I have already derived in one of the YouTube video. Okay, so if you have not gone through in details, please go through it. So what is the formula to calculate the work done by the gas on the isothermal process? W equals to 2.3026 nRT log of base 10 B2 by B1. Okay, so let's substitute the value. 2.3026, N is 1, R is 8.31. Yes, the temperature we have calculated is 400 log of base 10, and B2 means 2B. B1 is B, so B be cancelled out. Okay, now 2.3026 into 8.31 into 400. The children, log of base 10 with 2. Now you can use the calculator and calculate. Log of 2 with base 10, you get the value 0.3010. So please use calculator and check the log of base 10 with 2. You get the value as 0.3010. Okay. Now you multiply these three quantity, all four quantities. If you do multiply with the help of calculator, okay, you get approximately 2303.8, and definitely the unit will be joule. Means 2303.8 joule will be the work which is done by the gas in order to expand the volume, double the volume, in order to make the volume double the initial volume at temperature 400 Kelvin. So this is the work done by the gas isothermally. So children, I have even explained problem number 2, which is actually based on work done by an ideal gas under isothermal process. So there are 2 more numerical to explain, and that you learn in the next YouTube video.